What's up guys, welcome to Learning Math with Mr. Tan. Today we'll be sketching graphs of quadratic equations in completing the square form. It should be unfamiliar to you if you are attempting this activity. So completing the square form involves equations with a perfect square in it. So you have this x minus h square and a constant outside of it. So it can be a positive or negative of x square situation. However, in the first part, we shall use a positive x square situation to understand the concept before we go on to the examples. In the first example, we'll be talking about, again, the positive x square situation and how you work out certain information. Then, in example 2, we will work on the example with the negative x square situation. So if you see over here on the right, the Desmos template, which we'll be using later on, is readily available to you, is available to the public. You can just scan this QR code over here in the handout and go into this template to explore together with me. If you're learning this for the first time, please explore this together with me. Otherwise, if you are just looking to revise, then you can actually use the timestamp below in the description to go into the examples to see for yourself how to work out these informations. So let's start learning. So over here in this activity, I've already filled in the first row for you, where I put down h equals to 2, k equals to 3, and we're going to use the first row to understand this activity, what it means for us, as well as make certain observations which we will seek to generalize later on. Alright, so h equals to 2, k equals to 3 means my completing the square form becomes y equals to x minus h becomes 2 in square plus k becomes 3. So overall it becomes y equals to x minus 2 square plus 3. So notice that there are two important things that we're looking at for this activity. One is the turning point, the other is the line of symmetry. In the lesson on sketching graphs of factorized form, I actually related these two things where I first deduced the line of symmetry and linking that to the x coordinate of the turning point. So we'll be running through this one more time, assuming you have not done that lesson on factorized form. So we will be seeing how these two things are related. So over here I've set h equals to 2 and k equals to 3, and I'm going to first pick out the turning point, which is a minimum point over here. And Desmos tells me that the x coordinate is 2 and y coordinate is 3. So therefore in our handout we already filled that in, x equals to 2, y equals to 3 as a turning point, and the coordinates of turning points are 2 and 3. Okay, and we go back to here, and then the next thing we want to be looking at is the line of symmetry. So this line of symmetry is actually this vertical line running through the minimum point, and it splits the quadratic graph into two symmetrical parts. So I'm going to show you visually what that means. This green color dotted line is the line of symmetry of this quadratic graph. So if you can imagine, it actually splits it up into two symmetrical parts. If you kind of like flip the graph, you actually flip it over to the other side, and it's an exact match. So this vertical line actually happens to run through the minimum point. So unsurprisingly, the equation of the line of symmetry is x equals to 2, which coincidentally is also the x coordinate of the minimum point. So in the handout, we've already have x equals to 2 as our line of symmetry. And before I go on to the subsequent rows, I want to point out certain observations which we will be trying to generalize later on. So over here, first of all, notice that x equals to 2 and there is a x minus 2 over here. There's a y equals to 3 and there's a constant of positive 3 over here. So if I were to actually solve this x minus 2, sorry, let me just draw that properly. So if I were to solve this x minus 2, which means we set this to 0. So what it means is x minus 2 equals to 0. And I actually solve it. I actually get x equals to 2. which is this. And then we also have y equals to 3, which is the constant that is outside over here. So it seems to me that the equation of the graph actually tells me the x-coordinate and the y-coordinate of the turning point. So in the next row, I actually have h equals to 2 and k equals to 4. So that means for us, the equation becomes y equals to x minus 2 square plus 4. So we want to use Desmos to see whether the x-coordinate of the turning point remains at x equals to 2, and then the y-coordinate of the turning point is actually 4 now. Over here, we set h equals to 2, k equals to 4, and we locate the turning point. Over here, Desmos tells us that it is x equals to 2, k equals to 4. So that appears to be consistent with our previous observation. So previously we had h equals to 2, k equals to 3, and then we get turning point of x equals to 2, y equals to 3. Now we set h equals to 2, k equals to 4, and we have x equals to 2 for our turning point, and y equals to 4. So that seems quite consistent. Right, the next thing we want to be observing is whether the line of symmetry still remains to be x equals to 2, which is the same as the x-coordinate of the turning point. So let's go back to Desmos once again, and this dotted line still runs through x equals to 2. So it is still consistent that the equation of the line of symmetry follows the x-coordinates of the turning point. So this part, we are now convinced that our observations so far for two sets of h and k are quite consistent, and we want to stay on the lookout for the other sets of h and k, whether this remains consistent. So take this time to explore on your own for the next two sets of h and k on your handouts. You may also try more values of h and k, different combinations of things, whether the same things are still being observed, and then therefore you will be more convinced at what you generalize. Okay, so please feel free to pause this video for now and work on this, and when you're ready to check your answers, you may resume the video. Alright, so over to you now. And so I hope you have tried on your own this exploration, and hopefully you have even tried more values of h and k to convince yourself. So these are the entries you should be seeing on your handouts if you have done the exploration correctly. Okay, so one thing to note at this part over here, for the values of h and k to be -2 and -3, is just be really careful when you substitute h equals to -2 into the completed square form. It becomes x minus -2, so that results in it being x plus 2. Otherwise, the rest of things should follow. So you should be able to observe that the same thing happens again for these two sets of values of h and k. When h is 3, k is -5, you get x equals to 3 and y equals to -5 for your turning point. And I'll just briefly use Desmos to show this one. So over here we set h to be 3. Okay, so it can be a bit cumbersome to shift around, so you could just enter the value h equals to 3 and k equals to -5. So there we have, and needs to shift this graph a little bit, and we still observe the same thing. The x-coordinate of turning point is x equals to 3, and the y-coordinate of turning point is y equals to -5, and the line of symmetry is at x equals to 3. So that gives us the third row over here. So it seems quite consistent that the x coordinate of the turning point follows the value of h, and the y coordinate of the turning point follows the value of k. So essentially, for the general case of y equals to x minus h squared plus k, like the first situation where we actually solve x minus 2 equals to 0, you do the same for this and solve x minus h equals to 0. So that means, for example, let me just write somewhere else quite blank. And x minus h equals to 0 on solving gives us x equals to h. So we have x equals to h, and the y coordinate of the turning point follows this value over here. So y equals to k. So in coordinate form, it is h, comma, k. Alright, and the line of symmetry is x equals to h. Okay, so I hope this helps you to understand that for the completing square form, okay, the form for completing a square actually helps you to find the coordinate of the turning point, which leads you to the equation of the line of symmetry. In example 1, we sketch the graph of y equals to x squared plus 4x minus 2. Above it, there's a small section on recalling completing the square. It may look a little bit different from how you've learned it. That is actually a shortcut approach. You can use your approach, pause the video, and try to see whether you get y equals to x plus 2 squared minus 6 in the end. So whichever approach you do is fine. That is just a shortcut. It's not a conceptually complete approach, and then you can check whether you get the correct form later on. Otherwise, if you are comfortable with completing the square, you can just skip this part and go straight into the sketching. In the first part of the video, we explored and realized that the completed square form actually gives us the coordinates of the turning point. And what we did was to set the linear expression inside the perfect square to 0 and solve it. So it would look something like this. We set x plus 2 equals to 0. We solve it to get x equals to negative 2. And then the y coordinate of the turning point is just this constant over here, which is negative 6. So for coordinates of the turning point, we have negative 2, negative 6. Alright, and for the next part is we realize that the line of symmetry follows the x coordinate of the turning point. So x equals to negative 2 is also our line of symmetry. And then from the video on sketching graph using the factorized form, we realize that to find x-intercept, we actually substitute y equals to 0. To find y-intercept, we substitute x equals to 0. So for a bit more of exploration on that, please go on to that video to look for it. Otherwise, I'm just going to skip that part and go straight into the working out of the x and y intercepts. So for x-intercept, you can actually substitute y equals to 0 as mentioned and solve for the value of x. Alright, you can actually use a calculator. So depending on which brand or model of calculator, they may give you different functions for you to solve for the x-intercept. But otherwise, you can actually use algebraic method to solve it. So I'm going to go a bit on this instead. So what happens is your completed square form actually is y equals to x plus 2 squared minus 6, and you can set y equals to 0. You substitute y equals to 0 basically. So you substitute y equals to 0, and what happens is you actually have x plus 2 squared minus 6 equals to 0. And what you do next is to isolate the perfect square on the left side by moving the negative 6 over to the right hand side. So you are basically adding 6 on both sides. Okay, so you get 6 appearing on the right hand side. And to remove the square, you actually just take square root on both sides. But remember, you need to add in a plus minus to it. I'm not going to elaborate on this for this lesson. Okay, so you actually take square root, and what happens is you have plus minus square root 6. Okay, and x equals to negative 2 plus minus square root 6. Now that's going to be a bit fuzzy in terms of what negative 2 plus minus square root 6 means. So we need to use our calculator to find the value of x correct to 3 significant figures. So as it turns out, negative 2 plus square root 6 is going to give us 0.449 correct to 3 significant figures, and negative 2 minus square root 6 is going to give us negative 4.45, again correct to 3 significant figures. So now this gives us a better idea where our graph will cut the x-axis. You actually can proceed to sketch this graph, but otherwise you can actually find out more things, including the y-intercept as well. So you can actually find the y-intercept by substituting x equals to 0. So the expanded form over here actually can tell you that, because if you substitute x equals to 0, this x squared becomes 0, 4x becomes 0, and what you're left with is y equals to negative 2. Hence, therefore, I actually put y equals to negative 2 over here. So you're good to go. Alright, you can now put in all this information into the Cartesian plane. So over here we put x-axis, y-axis, so label them. And the first thing I'm going to put in actually is the x-intercept. It's a particular favorite of mine to actually put in x-intercept first, because I always want to know where it cuts the axis. Okay, so you can actually measure like negative 4.45 somehow cm away from the 0 over here. So you can measure like 4.45 over here, okay, and over here you can perhaps measure like 0.45, that kind of thing over here, and you have 0.449. You could put it in the third form as well, that's fine. And then for the y-intercept, you can just put in negative 2 over here. Okay, and you're actually able to sketch this. This is going to be a happy graph. Again, for an elaboration on what happy graph and sad graph means, you can go on to the video on sketching of graph in factorized form to look for my explanation on that. Otherwise, when it is a positive x square situation, you actually get a happy graph. Okay, so it's a smiling graph, therefore you get a minimum point as well. So over here, we actually can sketch the graph already, so it should look something like this. You can attempt to sketch. You can always refine it later on if you're not happy. So if I get something like this, and again I'm not too happy with it, I can actually erase it and redo it. Okay, and you may still encounter problems like this, so again you can just erase this part and redo. So perhaps after 1 or 2 attempts, or maybe 3 or 4 attempts, you get the graph that you kind of feel satisfied, and then you stop there. Okay, so the next thing you want to do is to fill in all the other information. Okay, you have your minimum point as well. So over here, you might want to mark out your line of symmetry to be passing through x equals to negative 2. Okay, and this leads you as well to the minimum point, and your y coordinate of the minimum point is actually negative 6. And then you also want to mark out your equation of the graph, which is y equals to x squared plus 4x minus 2. So now you're happy with this graph and you can actually stop here. In example 2, we have a negative sign outside the bracket, and this leads us to the negative x squared situation. So in the video I've done on sketching quadratic graphs in factorized form, we've already gone through a little bit about how this impacts the shape of the curve in the form of whether it's concaving upwards or downwards. However, in here, we are more curious whether this negative impacts the turning point of the graph. So here we will explore a little bit more about this. So here in Desmos, I have the blue color graph to describe the positive x square case, whereas a red color graph for the negative x square case. And the blue color graph is more properly described as concaving upwards, whereas I like to call it the happy graph or the smiley curve, whereas the red color graph is actually properly called the concaving downwards kind of curve, and you can actually call it a frowning curve or a sad curve. So we know what it means. And more importantly, I actually set the h and k to be the same values, so we can see for both situations whether they have any kind of similarity between them in terms of the turning point. So it turns out that the turning point over here is being shared by both graphs. And so this is a very important observation. That means this negative sign outside the bracket has no impact on the turning point. So we can actually proceed to deduce the turning point from the completed square form, just like we have done for the positive x square situation. We shall now proceed to sketch the graph, but before that we need to find certain important information starting from the maximum point. So the negative sign outside the bracket actually leads to it being a negative x square situation as mentioned before, and this is actually a set graph. And a set graph can only have a maximum point instead of a minimum point, so therefore what we're looking for is actually the maximum point first of all. So we're looking for the maximum point by using the completed square form. By solving this x minus 2 equals to 0, we actually can get the x coordinate of the maximum point. So therefore we get x equals to 2, which happens to be the equation of the line of symmetry as well. And the next thing we have is y equals to positive 1, which is a constant outside here. So therefore the coordinates of the maximum point is actually 2, 1. Now the next thing we want to find is actually the x-intercept, which is, like I mentioned so many times, is a very important point because it guides us in our sketching. So for x-intercept, what we need to do is to substitute y equals to 0 back into the equation. Now what that means for us is it becomes 0 equals to negative x minus 2 square plus 1. So if you add x minus 2 square on both sides, what you're going to end up with is x minus 2 square on the left, and on the right this becomes a 0 pair, so it disappears and you're left with a positive 1 on the right hand side. And after you take a square root on both sides, the left hand side there will be no longer any square, and then on the right hand side you have plus minus square root 1, which is actually just 1, so that's fine. And we have, upon further solving, 2 plus minus 1, so that means x equals to 3 or x equals to 1. Okay, so that's our x-intercept. So if you are required to put this as a coordinate form, then what you need to put is actually 3, 0. And that's because x equals to 3 and earlier on you substituted y equals to 0, so the y coordinate is 0. As well, the other set of coordinates is 1, 0. Again, y equals to 0. So that's for x-intercept. So you can actually just put in x equals to 1. So you measure using a ruler, maybe you measure 1 cm, measure another 3 cm you have over here, and you can actually sketch. But again, you may need more points for you to do a slightly better sketch, so you will need to find the y-intercept as well. So again, think of opposites. Y-intercept, you're really substituting x equals to 0. So if you substitute x equals to 0 here, what you're going to get in the end is y equals to negative 3. Alright, so if you have to put this in coordinate form, so your y equals to 3 means in coordinate form is -3 here, so that's y equals to -3, and x, since you have substituted 0, so x equals to 0 over here. So now we have all the important information. We can now start to label certain points in the Cartesian plane again. So for y-intercept, we have -3, so we can again measure maybe 3 cm, so we have -3. And we just put in 0 here just for reference, and we're now good to go. So we can now sketch this graph, and remember that it is actually a set graph, so therefore we actually can sketch it, and if you are happy with it, this should be fine. Alright, and do remember to label the maximum point, so it's halfway between 1 and 3 is 2, as earlier on we have found. X equals to 2, y equals to 1. Okay, so sometimes you need to check your work, and you realize that this 1 and -3 does not seem to be very proportionate, so you may need to adjust your graph a little bit. So I'm going to adjust the graph now. So after I've adjusted the y-intercept, it makes it a lot easier for me to sketch properly. And so now I will proceed to again label the maximum point. Okay, so that's 2, and just draw a dotted line leading to the maximum point, as well as leading to the y-coordinate of the maximum point, which is 1. And if you would like, you can actually draw a dotted line all the way through to indicate this is actually the line of symmetry, which is x equals to 2. And then finally, you finish the question by putting in the equation of the graph. So you can put anywhere, this is y equals to -x minus 2 square plus 1. So that concludes our 2 examples on sketching quadratic graphs in completing the square form. I hope this video has helped you to understand this topic better. So if you feel that this video has helped you to understand this topic better, please like this video. If you feel that my channel is helping you in improving math, please subscribe to my channel and spread the words. Thank you for watching this video.